Hello and welcome to Mr. Linford's math course. In today's presentation, we're going to be talking about solving absolute value equations. In particular, we're going to start by focusing on reviewing the absolute value and really defining what it is, and then getting into solving an equation that includes a single absolute value, and then ones that include multiple absolute value expressions. Now, first, we should remind ourselves what it means to be the absolute value of a quantity. Now, absolute value, there's a couple different definitions to it, and the definitions sometimes change as we work in different number systems. For us, I think the best working definition that we can use for the absolute value is that it's the distance, I'm going to put that in quotes here, the distance a value is from 0 on the number line. So we can say it's the distance a value is from 0 on the number line. Or we might even add how many units a value is from 0. So how many units a value is from 0? So absolute value really says, okay, whether you have a positive or negative number, all we want to know is how far away is this number from 0 on the number line. Now really, the idea of absolute value is that you're just really trying to get an understanding of how a value is in relation to other quantities on the number line. Okay, so if we're talking about a specific value, one of the things we want to know is how far away is it from 0? So you can think, when I say, what is the absolute value of 3? So in this first example, and I'm going to remind you that these vertical lines you see right here, those are the absolute value bars. So if I was to take the absolute value of a number, I would wrap it in these absolute value bars. They're these vertical lines that go around the number, okay? So if I was to say the absolute value of 3, that means how far is 3 away from 0 on the number line? So if you imagine that you had a number line here, and here's 0, 1, 2, 3, you would say, well, how many units away is 3? Well, hopefully it's pretty obvious that you're saying, well, 3 is 3 units away. That's the number. Being the number 3 means you have 3 units, so you're 3 units away. So what's the absolute value of 3? How far is it away from 0? Well, it's just 3. Okay, hopefully that's not, I mean, it should be obvious, but not too weird for you. Let's take a look at negative numbers. This time, let's take a look at negative 3. So we have 0, negative 1, negative 2, negative 3. How far away is negative 3 from 0? How many units? Well, hopefully, again, you're saying it's 3 units away, because you can count. 1, 2, 3. There are 3 units from 0 to negative 3. So we're going to say that the absolute value of negative 3 is also the value 3. You'll notice that these have the same absolute value. It's because we're saying how far are they from 0. And both the numbers 3 and negative 3 have the same distance from 0. Okay, they both share the exact same distance from 0. So if I said to you, I'm thinking of a number that's 3 units away from 0, well, you could guess the number 3, or you could guess the number negative 3. These both have the same absolute value quantity. Sometimes people think of the absolute value as returning the positive version of whatever number is on the inside. And that's an okay way of thinking about this. Basically, when we work with the absolute value, it's always going to be a positive number. Whenever you take the absolute value of something, it will always be positive, because for us, when we take the distance of something from 0, that's always a positive number, okay? So the absolute value will always be positive. You can guarantee that. Now, let's take a look at when we incorporate a negative sign kind of around the absolute value. So let's take a look right here. Notice that we have the negative of the absolute value. I have the negative on the outside this time. What this is saying is take the absolute value of 3. What's the absolute value of 3? Well, that's just 3. Then it says to make it negative. So our answer here is going to be negative 3. Okay? The absolute value was still positive, but then we had to make it negative at the end. So this comes down to order of operations. Absolute values are like parentheses in the order of operations, okay? You can evaluate the absolute value expression first and then apply whatever's on the outside, okay? So let's take a look at this example right here. I'm saying to first take the absolute value of negative 3. Well, the absolute value of negative 3 is just 3, kind of like what we had right here. So I have evaluated the absolute value of negative 3 to get positive 3, but then I have to make it negative. So I'm going to make it negative again, okay? Very similar to when working with parentheses or brackets, absolute value bars are also what are called grouping symbols. Like parentheses or brackets, we do those first in the order of operations. Now, something to point out, a lot of times I'll see people, they take a look at the double negatives here and they say, okay, negative, absolute value of negative 3. Well, we should, sometimes they'll say like distribute that, and they'll get a positive 3. And then the absolute value of positive 3 is just, well, 3. The issue with this is we cannot distribute into absolute values, okay? That is not allowed. We cannot distribute into absolute values, okay? Really, the distribution property only works for parentheses. Parentheses, brackets, braces, they're all the same thing. So that's the only time distribution works. The absolute value, yes, it's a grouping symbol, but it's an operation, okay? The absolute value means to do something, to apply something, okay? So absolute values are not parentheses. So I'm going to put a little note here for us. Do not distribute. Do not distribute into, and I'm going to abbreviate this, ABS values. Do not distribute into absolute values because they are not parentheses. They're not parentheses, they're not brackets, they're an actual operation, okay? Now, last one, the absolute value of 0. Well, if you just picture that on a number line, how far is, well, 0 away from 0? How many units? Well, that should be fairly obvious. It's 0 units away, okay? So, this is the only situation where you will have one certain possibility. So like if I said to you, I'm thinking of a number that's got an absolute value of 0. Basically, I'm saying I'm thinking of a number that's 0 units away from 0. Well, you would know exactly what that number is, wouldn't you? It's 0. Now, if I said I'm thinking of a number that has an absolute value of 3, I'm thinking of a number that's 3 units away from 0, you wouldn't know if it's 3 or negative 3. You'd have to take a guess. But if I said it's 0 units away from 0, you would know exactly what that number is. That's going to become helpful when we get into solving these equations. Let's take a look now at using this idea of trying to identify what the original value was, okay? Trying to identify what number has an absolute value. So in this situation, I'm saying take the absolute value of x, and that's equal to 4. There's some mystery number here, x, that when you take its absolute value, it's going to be 4. So this mystery number x, if we have a number line, it is going to be 1, 2, 3, 4 units away from 0. It's going to be 4 units away. Well, what number is x then? What value is 4 units away from 0? Here's this thing about working with absolute value equations. You don't always have certainty with your answer. Meaning, if I was to say I'm thinking of a number that's absolute value is 4, you wouldn't be 100% sure what that number is, because there's two possibilities. It could be 4, or it could be negative 4. So, we're going to say here, x could be 4 or negative 4, and that's the only answer we can give. It's one of these two possibilities, but that's as much as we can figure out, okay? So, what we're going to do here when it comes to solving these absolute value equations, we're going to really try to say, what is the absolute value equal to? So then what does that mean this interior part could be represented as? Let's take a look at an example first and then see if we can come up with a step-by-step process to work through. So in this problem, I've now given you an equation, right? I have 2x minus 1, and we're taking the absolute value of that, and we've set that equal to 9. So we're saying the absolute value of 2x minus 1 is equal to 9. I want you to think about this, and this can sometimes be a little challenging and take a little exploring, but I want you to think about this as, yes, we're trying to find x, but when we plug that in, when we multiply it by 2 and subtract 1, this interior, this whatever, this 2x minus 1, whatever that is, it's just going to be a number, right? You're plugging something in for x, you're multiplying it by 2 and subtracting 1, it's just going to be a number. All of this interior here. That number, whatever it happens to be, will have the absolute value of 9, okay? So this underlined value here, this interior quantity, whatever that number is, its absolute value will be 9. So what does that mean about what this interior could be? What does that mean that all this inside could be equal to? Well, hopefully you're saying that means that 2x minus 1 could be the number 9. We could plug something in for x and get the number 9 on the inside. Maybe whatever we plug in for x gives us 9, and then we take the absolute value of 9 and we say, well, that's just 9. But then there's another possibility. What if 2x minus 1 produced negative 9? What if this interior was negative 9? Because if we take the absolute value of that, we still get 9 back, so it works. So again, here's the situation. The interior quantity, this whole 2x minus 1 value, okay, it's just going to be some number. That whole interior could be one of two possibilities. So we have to account for that. We have to figure out what could x be to make the whole inside 9, and what could x be to make the whole inside negative 9. Because those are the two situations we can have. So when it comes to solving absolute value equations, you actually have to solve two separate equations. So first up, let's solve this first equation where 2x minus 1, we're going to pretend it's equal to 9. So we can add 1 to both sides. We can say 2x is equal to 10. If we divide by 2 on both sides, we get x is equal to 5. So if we plugged in the value 5, we would get 2 times 5 is 10, and 10 minus 1, that's just 9. So we'd be taking the absolute value of 9, and that would in fact give us 9, so that's true. Now let's take a look at the second equation to solve. Let's add 1 to both sides. Now we have 2x is equal to a negative 8. If we divide both sides by 2, we get x is equal to negative 4. So if we plugged in negative 4, and we multiplied that by 2 and subtracted 1, let's see, that's negative 8 minus 1, so that would be a negative 9. So we're taking the absolute value of negative 9, and sure enough, that does in fact equal 9. So here's the two possibilities. We said that x could be either 5 or it could be negative 4. It could be either of these because it makes the interior of the absolute value either 9 or negative 9. So we don't really have much certainty here. Like if I said I'm thinking of some mystery number that if you times it by 2 and subtract 1, its absolute value is 9. Well, you would do this work and you'd say, it's either 5 or negative 4. There's no way for me to tell for certain. I would just have to guess, but it's one of those two possibilities. So let's try to identify what we did here. And let's come up with a process for how to actually go and solve these absolute value equations. When it comes to the step-by-step, the first thing that you have to do whenever you solve an absolute value equation is to isolate the absolute, and I'll abbreviate that, value. You must isolate the absolute value. You have to get it by itself, okay? The reason is, once you have it by itself, then you can, write two equations, I abbreviate that EQS, so you can write two equations where the interior, I'm saying interior, I mean that as the interior of the absolute value. So you can write two equations where the interior is equal to the positive value. So you can write two equations, one where the interior is equal to the positive value, and where it is equal to the negative value. So you write two equations where the interior is equal to the positive and where it's equal to the negative. And then the last thing you need to do is just solve each. So go ahead and solve each of these equations. You're going to need really two answers for x here. So this is the process. Let's go ahead and use this process to really try to solve more elaborate absolute value equations. Ones that really require us to first isolate the absolute value and then come up with the two equations we have to work with. Okay, what I'd like to do is pause the video for a couple minutes, give yourself a chance to work through these three problems, and then we'll come back and check our work. All right, well, hopefully you had some time to work through these practice problems. Let's take a look at some of the work here and see if we can verify our answers. First up, you'll notice that we have the absolute value of x, then we subtracted 3 from that and got 20. So we're saying take some number, take its absolute value, and if you take 3 away from its absolute value, you get 20. So the first thing we should do is really figure out, well, what's the absolute value equal to? Let's try to isolate that. So I added 3 to both sides, so we are saying the absolute value of some number is really 23. Okay? So you're taking some number and take its absolute value, you get 23. So what could that number be? Well, again, we have two possibilities. It could be either 23 or negative 23. So those are our two solutions for x here. Let's try number 2 now. Notice that in the second problem, we don't have to isolate the absolute value because it's already isolated for us. So we're saying the absolute value of whatever this 2x minus 4 is 5. So that means 2x minus 4 is either equal to 5 or this interior is equal to negative 5. So I go ahead and I solve both of these equations. I added 4 to both sides. In the one I got 9, the other I got negative 1. And when we divide by 2, we get x is equal to 9 halves, and x is equal to negative 1 half. Again, we see that we have two solutions here for x, two possible solutions. And if you plug them in, they'll both work. One of the things I want to point out of what I'm doing here is I'm rewriting the equations. I'm not working with this equation. I'm working with these two possible equations. I'm saying, what could this interior be equal to? What I'm not doing here is this. This is what I'm not doing. I'm not working with the absolute value bars, okay? You'll notice I'm not adding 4 outside of the absolute values and dividing by 2. Instead, the blue equations that I wrote don't have absolute value bars in them. That's because I'm not working with this equation. What I'm doing is making 2 new equations. I'm just saying, what could this interior value be, okay? You cannot work by breaking the absolute values. So if there's a negative 4 on the inside, you can't really add 4 to both sides. It's not going to work out here, okay? Another thing that students tend to do that I want to point out that would be kind of dangerous to this problem is doing this process where they'll say, okay, well, this is just equal to 2x plus 4 is equal to 5. Because the absolute value makes everything positive, so this negative 4 should just turn to positive 4 and we're good. No. That does not work, okay? The absolute value here isn't saying make these two numbers positive. What it's saying is to make whatever the interior is, whatever you plug in for x, and you multiply by 2 and subtract 4, whatever that number is, whatever you get after you plug in x and evaluate it, that number needs to be positive, okay? So that's why I go ahead and I rewrite these two equations without the absolute value bars. You can see again in the third problem, first I do go ahead and I isolate the absolute value. I add 6 to both sides. And then I had a negative absolute value is equal to negative 6. So I just divided by negative 1, and I got the absolute value is equal to 6. You'll notice when I solve this, I wrote my two equations for the interior is equal to 6, and the interior is also equal to negative 6. I'm figuring out what I could plug in for x to make the whole thing either 6 or negative 6. They do not include absolute values. I'm telling you now, when you do your work here, do not include the absolute values, okay? Because we're not actually solving this equation, we're rewriting two possible other equations, okay? So don't do that mistake of where you break the absolute values, right? Where you're working by, let's say, subtracting 6 from both sides here, okay? We don't want to do that. So then when you do actually go ahead and solve this, you get x is equal to 0 and x is equal to 6. Those are our two possible solutions. Hopefully this is making sense to you. And you're seeing how we can utilize this process of going ahead to first isolate the absolute value, then writing the two equations, and then solving each of them. And you're seeing how that affects our solution. What I'd like to do now is to get ahead into solving more complicated absolute value equations, by this time incorporating multiple absolute values. Let's actually have 2 in this case. There's something we need to work with first before we can actually go ahead and solve these equations. First up, what we need to know is the equality of the absolute values. This property that states if you had two absolute value expressions set equal to each other, okay? If you had the absolute value of some quantity equaling the absolute value of the other quantity, what could we say about A and B here? What could we say about these two numbers, right? Whatever their absolute values are, and since they're equal to each other, what could we say about the original numbers? Well, we could say that the two original numbers are equal to each other, right? If their absolute values are the same, maybe they're the same thing. So for example, if we had the absolute value of 4, that's equal to the absolute value of 4, right? Well, then they're the same number. That's a total possibility. Are there any other possibilities? Is there any other situation? Or must it be that these two numbers are the same thing? Well, hopefully you're noticing we could have the same numbers here, right? The absolute value of 1 is equal to the absolute value of itself. Or you could have the opposite number. Remember, the absolute value of 4 is 4, and the absolute value of negative 4 is 4. So we can say that, so we can say that these interior numbers could be opposites from each other as well. So again, here are the possibilities. You could have the interiors be the same number, or you could have one is positive and one is negative. They could be opposites from each other, okay? So here's the situation. When we go ahead and solve these, we're going to need to again write two equations. So I'm going to say for the first step in the process, write an equation, I'll abbreviate that EQ. So write an equation where the interiors, are equal. Okay, so that's like where you set the two interior quantities equal to each other. Then we're going to write an equation where the interiors are opposite values. Remember, opposite means one's positive and one's negative. So we'll put that in parentheses here. One positive, one negative. Okay? So, once you have these two equations, you'll need to solve each of them for their value for x. Okay, you need to find what's the possible x value that would produce each situation. Let's take a look at some example problems and see how this process works. In the first situation, we have the absolute value of 3x plus 4 is equal to the absolute value of 2x plus 1. Again, you're going to plug something in for x, and you're just going to get a number here and a number here, okay? The left-hand side, that absolute value is just a number. The right-hand side, this absolute value is just a number as well. So we could say that these interior numbers are in fact equal to each other. We could say that they're the same number, and we could solve for x. I'll subtract 2x from this side, and I'll get an x plus 4 is equal to 1, and I'll subtract 4 from this side, and I'll get x is equal to negative 3. That's a possibility. If I plug in negative 3, I get 3 times negative 3 plus 4, and that's negative 9 plus 4, the absolute value of that, and that's the absolute value of negative 5. Let's see what that's equal to. On this side, I would have 2 times negative 3 plus 1, Let's see, that's the absolute value of negative 6 plus 1. That's the absolute value of negative 5. Hey, it works. They're the same quantity. They're both negative 5, and obviously their absolute values are going to equal each other. So it works. Negative 3 is a solution for this. But keep in mind, you could have them both be the same, or one could be the positive version of the other, or the negative version of the other. So what I'm going to do here is I'm going to say the other equation could be 3x plus 4 is equal to negative quantity of 2x plus 1. You'll notice I wrapped all of 2x plus 1 in parentheses and I put a negative on the outside. This is how I'm going to take the opposite of 2x plus 1. Okay? I'm going to say 3x plus 4 is equal to negative 2x minus 1. I flipped all of the signs here, okay? I've switched all of the positives into negatives. So now I can solve this equation. What this is allowing me to do now is saying, what if one's the opposite of the other? In this situation, I decided to make 2x plus 1 negative, or the opposite. You could have done the same thing to the left-hand side. This equation right here is equivalent to negative 3x minus 4 is equal to 2x plus 1. You could have made the left-hand equation the opposite, or the negative one. It's up to you. It doesn't matter. These are the same equation, okay? To get one into the other, just multiply both sides by negative 1, and you'll see that you get them right back to each other, okay? So you choose which one you want to be negative. It doesn't really matter, okay? I'm just in the habit of choosing the right-hand side to be negative, so that's why I did that for the 2x plus 1. So now I can add 2x to both sides. And you know what? While I'm at it, I'm going to subtract 4 from both sides. So I get a 5x is equal to negative 5. And if I divide both sides by 5, I get x is equal to a negative 1. So if I plugged in negative 1, let's see, we get 3 times negative 1 plus 4. Oops, and that's the absolute value is equal to the absolute value of 2 times negative 1 plus 1. Negative 3 plus 4, its absolute value is equal to the absolute value of negative 2 plus 1. Well, negative 3 and 4 makes a positive 1, and negative 2 and 1 is negative 1. And what do we know? Here's a situation where we have the interiors are opposites from each other, but that's okay. Their absolute values are still the same thing. So, again, you can see when we work through this process, we're still writing two equations. One where the interiors are equal, and one where they're opposites from each other. I am not working by actually solving the absolute value equation. I'm not breaking the absolute value bars. So I'm not saying minus 1, and I get a 3x plus 3 is equal to the absolute value of 2x, and then, subtracting 3x. I'm not doing this. This is not accurate, okay? You cannot write like this. You cannot break these absolute values. That's a big notational error, okay? What you have to do is you have to work with the two possible equations for what the interior could be. That's how I want you to solve all of these problems. So pause the video, take a minute, go ahead and give this problem a try and see if you're able to come up with the correct solution. All right, well, hopefully you're able to set up these two equations. You'll notice that the first one has the interiors set equal to each other. We're assuming that they're the same number. And then the second situation, I took one of the interiors and I set it equal to the opposite of the other interior, okay? It doesn't matter if you said 3y plus 1 is equal to the opposite of 2y minus 7, or if you had the opposite of 3y plus 1. So if you distributed the negative over there is equal to 2y minus 7. These are the exact same equation, okay? Same thing, and you're going to get the same solution. So you choose which one you want to be the opposite. But let's go ahead and let's take a look at some of the work for how we go ahead and solve these. So as we work through each of the problems, you'll notice that for the first one, I get y is equal to negative 8. That's would produce a value where the interiors are the same quantity. And when I go ahead and distribute the negative here, you'll notice that my signs change. I get a negative 2y and I get a positive 7. Okay, what I've done is I've distributed a negative. I've changed all of the signs. Sometimes students think that if they have one quantity equal to the opposite of the other quantity, then they say, okay, instead of having 2y minus 7, I need to have negative 2y minus 7. Sometimes they don't change the negative sign. For some reason, they leave it and they say, well, isn't negative the opposite of an absolute value? That's where people are getting kind of confused about what the absolute value means, okay? This would not work here because this isn't the opposite of this. They're different expressions, okay? The opposite of 2y minus 7 is negative 2y plus 7. That gives you the value that's a different sign from just positive 2y minus 7, okay? Don't get thrown off by making up your own rules about absolute values, okay? This is where people really get tripped up. A lot of times, most of the confusion people have in math, in particular around absolute values, is they're making up rules and they're getting tripped up in these made-up rules. Like I've met with students that have written this before, and they say, well, negatives are the opposite of absolute values. And I go, what does that mean? Well, no, because just because an absolute value gives you a positive number, you can still have a negative on the inside. That's allowed, okay? My best advice to you is to stick with the process. Get the process down and just stick with it, okay? Do your step-by-step where you write that you need to have one side be the negative, okay? And then show how you distribute that through. That will help you out best here. So you'll end up with your two solutions. Here I got y equals negative 8, and for the other one, let me write that a little neater. It's y equals 6/5. Those are the two solutions. You can actually go ahead and plug them back in and verify that you'll get the same quantity when you plug in negative 8, and you'll get opposite quantities when you plug in 6/5. Let me know if you have any questions about this content, or if you need any help working through any practice problems or more explanation. Feel free to email me with your comments or questions. My email is klinford, that's KLINFORD, at wccnet.edu. Let me know what you thought of the video, if you have any questions, and until next time, take care.